Hi, welcome to another IELTS writing video. In today's lesson, I want to demonstrate how to approach Academic Task 1 diagrams. So we're going to look at an Academic Task 1 diagram and analyze it and write the response from start to finish. If you find this video helpful, visit my blog at IELTS.com and join us at the forum IELTSnetwork.com. So if you've been watching the series all along, at this point you should be comfortable with identifying data sources and the trends that exist within them. Diagrams are a little different in that their nature can vary widely. So some diagrams could illustrate spatially sensitive data, like a map, for example, or like a piece of machinery. Other diagrams can illustrate the manner in which something functions. Some illustrate a linear process, and some might illustrate a cyclical process. So diagrams really challenge your ability to be dynamic and flexible with your language. So today we are going to look at this Task 1 diagram. The task description reads, "This diagram demonstrates how hydroelectric energy is generated. Summarize the information in at least 150 words." Okay, so very straightforward. Now the diagram itself, let's see if I can squeeze everything in here. Okay, so in this data source we see how water and the energy it produces is evolved into usable electricity. As you can see, the process is both cyclical through rain and the manner in which the reservoir water is transferred and pumped back into the reservoir. And the process is also linear in the way the electricity is produced and transferred to residential and industrial areas for consumption. So we're going to use language that will appropriately demonstrate both the cyclical and linear nature of this data source. So when you begin analyzing a diagram that shows a process like this, it is of course important to first understand what the process is and exactly what's going on in the diagram. So before putting pen to paper, ensure you know where the process begins and where it ends. Having a mental understanding of this and a general understanding of the little steps incurred along the way can help you produce a more well-rounded answer. We've already decided what the type of data source this is and what it shows. So this takes care of the introduction paragraph that we're about to write. So as you know, this area of your writing is a general declaration of what is being described. As far as the starting point is concerned, we can see that the process begins with water evaporating. So this is where we will start our description in the second paragraph, otherwise known as the analyzing paragraph. I think what we might do is we will also separate the linear part of the diagram from the cyclical part of the diagram. So where you see reservoir and the dam and the valve opening and closing and allowing the water to flow into the turbine, and then it goes to the pump and it's back to the reservoir. We'll describe that process in detail, and of course including the steps that come before that, the evaporation and the rain. So we'll describe that in one of the analyzing paragraphs, and then in the second analyzing paragraph is where we will describe the linear motion that exists for the remainder of the diagram. So as you know, the first couple of sentences provide an overview of what the data source is showing, and then reveal any broad trends or broad details that we might want to include as part of the overall description of the data source. So the diagram shows the hydroelectric power generating process. And then we might, as a broad trend, just point out that it's both cyclical and linear in nature. And we might also, state that for the first part of the process anyway, there is some dependence upon natural forces. So let's say according to the image, the process contains both cyclical and linear stages, let's say, and is let's see, something about its natural dependencies, is highly dependent upon natural rainfall and the force of gravity. Okay, so that's a nice little sort of overview of what exactly the data source is showing. Now let's go to the first analyzing paragraph, and as I pointed out, we're going to be talking about the first couple of stages right up until the point where the energy of the flowing water is converted into electricity in the turbine. So let's find the starting point and just state that clearly. So the process begins when the sun's rays evaporate water. Okay. And so then, as you can see in the diagram, so the water turns into a cloud, and as the cloud gets heavier, it produces rain. So this evaporated, please notice the bit of cohesion I'm sticking in here, so I'm linking my sentences together. This evaporated moisture forms clouds, and is precipitated, we'll say precipitated back to the earth as rain. Okay, and then so some of this rain is collected in a reservoir. We'll just stick this together. So in a dammed reservoir. We can just talk about the location real quickly. So located at the base of a mountain. I think it's significant to point out that there is a strategy to where this reservoir is placed, because then you can use the force of gravity to your advantage, so that the water naturally flows downward and creates energy as it moves. And so pointing out that that the reservoir is located to take advantage of this is important. So let's see, some of this rain is collected in a dammed reservoir located at the base of a mountain. So let's just stick in then, which uses the Earth's gravitational pull to let's see, enhance water collection process. Firstly, so as you can see, it's running off of the mountain and into the reservoir. The dam is connected to a valve. I don't think we need to stick in any sort of description. I mean, I know that in the data source it mentions that the valve opens and closes, but just the nature of a valve is opening and closing. So I don't think I need to stick in any more detail regarding that bit of text there. So the dam is connected to a valve that allows the water to flow downhill and into a turbine. And then, as we were saying, so what the turbine does is it's converting the kinetic energy produced by the water as it flows downwards into electricity. So let's just stick in, so into a turbine where the kinetic energy of this moving water is converted to electricity. The water is then directed, and just the kind of circular motion or the cyclical nature of it, so directed towards a pump and returned to the reservoir, okay, or maybe even for future use. Okay, so let's just take a quick look at that paragraph, make sure we've described everything properly, and I'll stick in a page break so we can see it all on one page. So the process begins when the sun's rays evaporate water. This evaporated moisture forms clouds and is precipitated back to the earth as rain. Some of this rain is collected in a dammed reservoir located at the base of a mountain, which uses the earth's gravitational pull to enhance the water collection process. The dam is connected to a valve that allows the water to flow downhill and into a turbine, where the kinetic energy of this moving water is converted to electricity. The water is then directed towards a pump and returned to the reservoir for future use. Okay, let's talk about the remaining part of the diagram, so the more linear flow of what's being transferred here. So there's electricity in the turbine, we've already mentioned that. Now it looks, if we look at the diagram, so through high voltage cables, this electricity is moved to a transformer station, and I imagine that the transformer station would convert the electricity into a form that's usable by well, we can see it gets transferred to residential and industrial areas. So we sort of have this raw electrical energy, and the transformer is just changing that into a form that can be used or can be consumed safely. So let's try something like the electricity produced by or in the turbine is channeled, we could say, I guess, or maybe routed to a transformer station, and this is through or via high voltage cables. The transformer station converts the electricity to a usable energy and transfers this energy to residential and industrial areas through underground cable. Okay, and that's pretty much the end of the process. We might just want to stick on that. I guess the very, very final stage is that the energy gets used. So energy consumption marks the final stage of the process. Okay, and that would be the end of our response. And so when talking about linear diagrams, typically you're going to find that the last sentence is just the last step or the last stage in the process. Some people like to save the last sentence to make their kind of broad statement about what the data source shows, and that's fine. I prefer to put that at the beginning because it's a nice way to introduce and warm the reader up to what you're about to talk about. So you kind of start sort of broad, and then you get into the more minor and minute details of the response. So I think that is about all I want to say about Task 1 diagrams, cyclical and linear diagrams. I hope that tutorial was helpful and that you're walking away with a few wording styles that you can put into your own Task 1 responses. Thank you very much for listening, and have a nice afternoon.